So we're in the last chapter of your chemistry book, chapter 18, and we're talking about hydrocarbons. This is in section 2, which is kind of a long section here. We went over alkanes, alkenes, and alkynes, and aromatic hydrocarbons. And now we're going into what is the source here. You can see some of the sources of hydrocarbons, and you see here hydrocarbons we think of. Here's a drilling oil, so oil, hydrocarbon. Here's a super tanker at sea needing oil. Here's the transelastic pipeline, oil pipeline. These all have to do with hydrocarbons, right? And on to the gasoline tanker truck here that we see, the sources and uses for hydrocarbons here. So petroleum. So the vast quantities of hydrocarbons are petroleum based, right? Petroleum is a crude oil, and it's a complex mixture of different hydrocarbons ranging from very heavy alkanes to very lightweight aromatics. So hydrocarbons. Although known since ancient times, petroleum became a very valuable commodity in the 1800s. So why in the 1800s? Well, because they discovered that it can be separated, oil can be separated into its components by a process called fractional distillation. So petroleum then could have certain products taking out, which like kerosene became replaced then. Kerosene, as you distilled out the products and you got kerosene from there. The kerosene was then used and replaced whale oil. Whale oil was used in lamps, which of course they were killing lots of oil for a lot of different lamps, right? And so now they decided to use kerosene. And so this lamp lighting caused basically petroleum, to be needed in the 1800s more. And then it also spurred additional demand for petroleum as the rise of plastics and synthetic fibers at that time in the 1940s. And so petroleum's used for a lot of different products now. As we know, petroleum is used for many things, including plastics. And so petroleum extraction and refining is very important, as we see in the refineries. This is being one refinery here. So that petroleum refinery being very, very important. But what do they do on that refinery? So and first of all, how do they do this? They extract from the ground or from under the sea by drilling a little hole where the petroleum deposits exist and pumping out the oil, right? And then it's transported to the refineries or pipelines. They basically, by pipelines here, transfer the oil to the refineries so it can be distilled. And distilling is basically taking portions of that out. Let's see, where am I? Okay, here we go. So crude oil can be separated by fractional distillation because the individual components or fractions of the mixture have different boiling points. So each boiling point, as it boils at a certain point, they'll take out at that boiling point, they can take out that type of, that fraction of the oil. So that's what's called distillation, right? Let's see, it says C9, oh, we're not going to go that. The petroleum was first heated to boiling and then injected into the bottom of the fractioning column. And as the petroleum vapors rise to the top, those portions are taken out and the various fractions are condensed at different levels, depending on their boiling points, allowing them to be drained off. The lightest hydrocarbons, which would be the methane, ethane, propane, butane, they do not condense at all, and they'll be extracted from the top of the column because they're the lightest. Propane and butane are later separated from this mixture by cooling it at room temperature and compressing it, So taking it. So here we have the picture of it here. So here is the fractional distillation of petroleum. So as the crude oil comes in here, it's going to be heated at these high temperatures, 650 degrees Fahrenheit here. The residue and tar is going to be coming out the bottom. Then you have the heavy distillates, which are the lubricant or oil and grease and the wax here. And then above here you have the heating, the oil of fuels, then kerosene. And then at the top you have these are naphtha, will be the paint thinners industrial uses and gasolines up here, gasoline above that, and on to the gases such as methane, ethane, and propane gas, LP gases at the top. So this is how they do it. Pretty easy. They basically heat it, and they at each place that as it's heated up and the boiling point. See, it starts at 650, going at 650 degrees, going up to as it goes up from to six, or goes actually the decrease and as it decreases, and then the distillates come out. So it starts at basic 750, 600, 540, 380, 300, 225, and they're taking out these vapors. See how the vapors are taken out. So it says gasoline is one of the most valuable petroleum fractions, but only about 20% of crude oil distills to gasoline. But they need that gasoline, right? See where the gasoline comes out from the top, towards the top with the natural gas. So to increase this amount, some of the heavier distillates are broken into smaller molecules by heating them under pressure. And they call this heating under pressure cracking. And they have a catalyst, and it's cracking these larger pieces up, so they do that too with the cracking. So here we have the fraction of the number of carbon atoms in these alkanes. These are alkanes, all petroleum products, right? And so we have the number of carbon in the alkanes. We have the natural gas having the less carbons onto the gasoline, kerosene, heating oil, lubricating oil, residue, all that we saw there. And then we have the temperatures where they distill them off. And we have on to what they use them for: natural gas, fuel, starting materials for plastics, gasoline, fuel, of course, gasoline, diesel fuel, jet fuel, home heating. All of these are kerosene. Heating oil, industrial heating, conversion to gasoline, lubricants, lubricant oil, residue, paraffin, wax, asphalt, these kind of things. These are all what we get from petroleum products, which it's pretty amazing. So let's go here. It says natural gas is usually found along with petroleum, and it's up to 97% methane. And it contains hydrocarbons and varies in composition. So natural gas is pretty important too. Also, another thing that's very valuable as a hydrocarbon, besides oil, we have natural gas and we have coal. Coal is 45 to 95% carbon. So when you think of coal and how we've used coal in the past, very important throughout history, and basically keeping people warm and all. And as it burns is carbon, so is a hydrocarbon. So along with elements of hydrogen, nitrogen, oxygen, and sulfur. But anyway, they're all inside of coal, and it's a major energy source there. So let's go on here. So going back here, important here, I didn't see. It says, next to its use as energy source, coal's most important use is the source of coke for iron. So when you see coke, you're going to be thinking of coke, you're thinking of coal, you're thinking of coal used carbon. Coke is carbon, and to actually bring forth steel from iron, you need coke, which is carbon. I think we learned that in another chapter. But coke is considered carbon and basically coming from coal. So the compounds in the coal tar that result from the production of coke have made many uses, such as drugs, dyes, and road surface, but also used in the manufacture of steel. So important. Hydrocarbons and similar compounds include diesel fuel, jet fuel, natural gas, manufactured biological sources. They can manufacture soybean oil, jojoba oil, and bacterial fermentation of plant manufacture. They need petroleum for all of these things. So anyway, so a couple other things I want to talk on this video, and we'll get to it. I'm going to go back here to something that we just went over when we were going over the aromatic. Here we go. This is back here. even further. Graphite. So we were talking about aromatic. Let's go back one and show you what we're talking about when this came up. So this article here is pretty interesting. We were talking about polycyclic aromatic hydrocarbons, PAH, right? We're talking about those are very unusual. Some PAH are carcinogenic, it said, but a lot of them are not. It depends, but there's a variety of these. We went through these in the last video. But as we go here, we see the most common and familiar form of carbon is graphite. So we're going to talk about graphite, fullerenes, and nanotubes in this article. So I thought this article was pretty important for us to know about this. Graphite, what is graphite? I'm just going to go through it kind of simple. I'm not going to read the whole thing, of course. Oh, this is Buckminster fullerene. This is one of the biggest molecules. It's carbon with 60 carbons in it. Can you imagine that? So, and this is going to be a type. Well, let's talk about graphite. And if you look in the lead of your pencil, it's probably considered graphite, right? Mainly graphite. It's also used in electric motors and such, and temperature electrodes and powdered lubricant, all of these different things. Graphic on a microscopic scale consists of flat sheets of carbon atoms that slide easy over one another. And you would call them, the graphite is like crumbly and it's very soft in form. But despite the softness, individual graphite sheets are called graphene, but it's very strong. This is very strong. It exceeds the strength of steel and even exceeds the strength of diamonds. Can you believe that? And each sheet can be thought of as a very large polycyclic aromatic hydrocarbon. Remember, we're talking about the hydrocarbons. They're not alkanes, they're not alkenes or alkynes. They're aromatic hydrocarbons. It's called PAC. And these consist of millions or billions of aromatic, billions, can you think of billions of aromatic rings? And the sheet is edged with all of these hydrogen atoms along with the carbon, but it's so large, the percentage of hydrogen in any sample, you can't even, is negligible. For this reason, graphite is not even considered a hydrocarbon in the midst of all of that. So it's just all of this graphite. So it's unusual. And so now it says in recent decades, they have had a lot of interest in these, of course. You can see how they would. And when graphite is heated at very high temperatures, pieces of graphite can break off or evaporate and recrystallize into these smaller clumps. In 1985, scientists were surprised to discover that small sheets of graphene produced and rolled up and bonded at their edges to form these spherical molecules of carbon. And this is what they called, because it was named after R. Buckminster Fuller, they call them fullerenes. He lived in 1895 to 1983, and he invented the geodesic dome, which the molecules resemble like it. They thought it looked like a dome. But here's the Buckminster fullerene with 60 carbons. And they ended up rolling up in that situation with the Buckminster fullerene. So, and it consisted of 20 benzene-like rings bonded together making, you can imagine. Another says an even more exciting variant of graphene discovered in 1991, another kind. Under conditions, the graphene sheets, they didn't form spheres, but instead they rolled up into these little tubes called nanometer tubes. And these tubes can be made in different lengths, just a few micrometers and several kilometers to several kilometers. Well, kilometers are huge. So anyway, kilometers onto, so they can be small. They're known as carbon nanotubes. So here we have a close-up of a nanotube right here. So you can see these carbon nanotubes, and they're very strong. These tiny tubes, They're the strongest of the strongest filaments known. And in fact, they make cables 100 times stronger than steel. Can you imagine? And they can support the weight of 8,500 ton ship. Can you imagine? And a fishing line of these can pick up a truck. They're excellent conductors of electricity. They're as good as copper, and they're also used as semiconductors and insulators. They can be added to the paint to conduct electricity in paint. And they're hollow, so they can use these little tiny capsules can use as pipes to put fuel in. They're semi-permeable membrane in electricity, and they can be generated for these fuel cells. So they strengthen textiles. That you can use them in textiles and be your clothes can be like armor. They'd be so hard, like military armor in your clothes. And they're very lightweight and so high strength. You can you can use them as bulletproof vests, So this is pretty neat. Graphene, fullerenes, and nanotubes. New things for graphite. And graphite being, when we talked about those aromatic hydrocarbons. So here we have that. And another thing I wanted to go over is the other article. So this article is so important. We need to know, because everybody's talking about climate change and global warming, right? And what carbon dioxide. We don't want to have so many people that are breathing out carbon dioxide and such. So what in the world is this all about with global warming and having too much? In fact, now they're saying they're going to monitor how much carbon dioxide you breathe out. So when I think of this, I just get out. It makes me pretty angry, But anyway, so this article is really a good article on this subject here. So let's see. I have the article here. Okay, carbon. Okay, here it is right here. Oh, it's written. So I'm not going to read it to you, but I'm going to go over it. So first of all, we have what's called the greenhouse effect. And that's a good thing. It's what God put together, basically making our planet like a greenhouse sometimes. So this keeps the Earth's temperature at a range that's suitable for all living things, right? So it's a good thing. And in the day, the radiant energy comes from the sun and our atmosphere, which consists of, basically the gases responsible for keeping in this heat would be water vapor, which is, 94 to 98% water vapor actually keeps, as we have the clouds and such, they keep in for the greenhouse effect, they keep that all in, right? And so there's water vapor, and then carbon dioxide is one. It also, living things put off as we breathe, not living things, I should say animals and people, as we breathe out carbon dioxide. Plants love carbon dioxide. They need carbon dioxide, really. So it's kind of neat. As we exhale our carbon dioxide, the plants need it to do their photosynthesis. It's how God put things together. So now we have what this is called is that greenhouse effect. And this is really important, is to have a greenhouse in the winter. If we didn't have the greenhouse effect in the winter, we would have some problem, wouldn't we? In fact, it says right here, without the greenhouse effect, our average temperature would be very cold, like basically frigid would be negative 18 degrees below zero, or negative 0.4 Fahrenheit, nearly 60 degrees colder than it actually is now if we didn't have it. So it's how we need that greenhouse effect, how it's important. So global warming. So let's talk about what this global warming is. See, some scientists have speculated that mankind's production of carbon dioxide, and also carbon dioxide is produced from fossil fuel combustion, agriculture, especially, our animals and such producing methane gas or producing carbon dioxide. and cement manufacturing, these produce carbon dioxide too. So they say that too much carbon dioxide will enhance the greenhouse effect. And so that we'll have average global temperatures rising. And this will contribute to carbon dioxide, but when we think of man's contributive carbon dioxide, it's so small compared to nature. Because basically nature in itself produces 29 billion tons. You think of all the things that happen in nature, billions and 85 billion tons of carbon dioxide. And so, but the scientists are, basically we're worried that the small increase of having more people on Earth or producing more carbon dioxide would change our global climate. And so then they even had gone further, predicting, oh no, if we don't stop this, if we don't stop our population, if we don't stop these things of the manufacturing industry closed down, giving off carbon dioxide, we're going to end up with flooding and disease and epidemics and famine, all these things, and even the extinction of the whole human race. So that's what they're thinking about climate change. But I like this part, if we looked at the climate history of the Earth, we'll say that, we've had these times where there was a warming period, that we went through in history, going through a warming period, and other times going through, an ice age, and this has gone through history. So basically the history goes in cycles, that the Earth's climate tends to fluctuate over long-term cycles. And we can look at these cycles through history. One of them is this medieval climate optimum. And this was between 900 and 1100 AD. And basically back then it got pretty warm. In fact, it was so warm that the Vikings, they started having farms in Greenland and even on to Iceland, even coming to, Canada, this area, when you think of Leif Erikson, but it was warm then in comparison. So the Vikings actually thought they could live there. In fact, the Anasazi Indians at the same time, they thought the same thing. And so, they built, all of these, you can see Anasazis if you go in Colorado, and you can see where they built, on the Colorado Plateau, which is usually pretty cold and cold winters, that they had a time where, they could plant agriculture based at that time. But in the 1300s, so we have in the 1300 from that, by 1300s, this global temperatures dropped and plunged, and they had called it the Little Ice Age. And so Greenland was covered with ice, and Vikings, they lived or died out. Leif Erikson, his group, what happened to them, we don't know, basically the poor crops to the Anasazi, and they ended up having epidemics because of, the weather, and it ended the Anasazi civilization. Even the Thames River in England froze. The American colonists during that time, when we go on, later on, we see the coldness, they still have, not as severe, but in the Carolinas, it says about 1850, the climate began to be warm again and gradually ended the Little Ice Age, 1850. So before in the 1700s, it was pretty cold when the Pilgrims came to Plymouth Rock, colder than it is now. And so in the 20th century, and it got warm again for a while. And this continued until 1938, when temperatures began to get cold again. So we went through all these cycles. We can look at this in history. This is just historical. So here's a picture. I like this picture anyway. So as late as 1970s, the unusually cold winters prompted environmentalists to call for a drastic government to save the planet from global cooling. They didn't call it global warming. They called it, that's in my time. They said, it's going to get so cold, we're going to have an ice age, an imminent ice age is coming. So in the late 1800s and 1990s, temperature once again began climbing. And then they said, we're going to have global warming. I thought we were having global cooling, you know, and temperatures began to climb again, corresponding to the solar output anyway. And again, trying to save the climate change protocol, you know, came to be. Anyway, the Kyoto Protocol. So when we talk in 1992, they had environmentalists got together and had an Earth Summit meeting in Rio de Janeiro. And Maurice Strong was the head of this, and he was a radical environmentalist. He invited 150 nations and said, we're going to use the United Nations framework on climate control. And he was basically said that they were going to slash carbon dioxide emissions from all of the developing nations. So they said only some nations. We're only going to do this for some nations. And so in saying that, the Kyoto conference, first meeting in Rio de Janeiro, and then as they met again in Germany, you know, they called this Kyoto Protocol in Japan in December of 1998. It keeps going on. In 1995, they had this the second UN conference in Berlin, of all places. And then they said they were going to drastically reduce carbon emissions by 2012. They met with President Clinton, was president then. He signed it, but the Senate refused to sign it. So America did not really sign the Kyoto Protocol that said that we had to take care of, get rid of carbon dioxide, carbon emissions, right? And so in the midst of this, they said we'll go on to 2012 and we're going to end in 2020. In 2020, we're going to make sure that we have this protocol, that we're going to make sure that we don't have too much carbon. The big problem was, especially during President Clinton's time, was that, you know, they were having America, they were coming to America and a lot of the Western civilizations in Europe, but they didn't really do anything about China. And really China basically had most of the carbon emissions from their factories and such in China. And they did nothing about the nations in India too that produced. They said, oh, we're not talking about them. We're only talking about the Western, you know, the developing nations. And that was like, if you're talking about the world, you should talk about the world, right? So anyway, going on, after this, they said now they're extending it on and instead extending it to our time. Let's just say that. So, but when we look back, there's some benefits for us to have some global warming. The way God, you know, put us in cycles, there's some benefits. And I go over the benefits here, saying, you know, during some times the warming was good. The cycles of Earth were benefit to the planet. And then we needed the carbon dioxide. The crops needed the carbon dioxide, you know, and if we didn't have carbon dioxide, the crops couldn't grow. And onto aspects of better living conditions, longer life expectancy, reduced disease, better nutrition, you know, during these 10-year cycles where the globe warmed, where there was global warming. And so, but the thing about the big thing that really, you know, should get us, you know, upset about what they're doing is that they're calling for drastic changes in, first of all, the redistribution of wealth, saying we are going to control your money so we can use your money for our issues, and we think this is an important issue. And so the redistribution of wealth is communism. So they have a communist background. Another, mandatory population control, you know, with abortions and such, and on and on. That's pretty sickening. And then the big thing is they want to surrender each nation's power to the United Nations. The United Nations can take care of it, and we'll take care of the climate of the world. That's leading to a new world order, which is going to drastically, as it's leading to in the Bible, talking about and a figure, an antichrist figure, as a leader of the world. So we're looking into global catastrophe in the midst of all this, but maybe that's prophesied exactly what's going to happen in the end times. So when you look ahead, I like this. Global warming debate will likely continue for some time to come. As Christians, however, we can be certain, while the earth remaineth, seed time and harvest, and cold and heat, and summer and winter, and day and night shall not cease. From Genesis 8:22. Although we should do all within our power to protect the world God has given us, we must always remember that the fate of the earth rests in the hands of the Creator. Amen. Amen and amen. So we've looked now on section 2. We're going to go on the rest of 18, and then we'll be done with chemistry for this year.